Okay, let's begin. Thank you very much for participating and for your interest about our open call, about our project. I'm Michael Batistatos. I'm from Demokritos. Demokritos is the coordinator of the project. And today we will give you some first information about the open call, the project, Agrarian, and the platform for your application. So let me share my screen. And now I guess you can all see my screen. So this is the first info day. We have 2 info days for this open call. This is the first one. So during this session, please keep your microphone muted. This session is being recorded. And in case you have any questions, we have a session in the end of the meeting dedicated to questions and answers. But please write all your questions in the chat, and we will try to address them in the end of the meeting. And if there is no time, enough time, then we will record your questions and we will answer them later, and we will send them via email. So the agenda for today, first I will give you a project, an overview of the project and the open call. Then we will present testbed number 3. We will talk about that in a while. The agricultural dataset that Agrarian provides. And then we will demonstrate and present a little bit the platform that you will use in order to make your application. And then in the end, we will have the Q&A session. In general, Agrarian is a Horizon Europe project with 13 partners from 9 different countries. We have 3 pilots in Greece, Romania, and Portugal. It's all about innovative technologies in agriculture. The project duration is 3 years. So we are in the end, we are approaching the end of the first year of the project, and Demokritos, the National Center of Research in Greece, is the coordinator. Agrarian targets mainly to the developers, to the end users, and to the policymakers. So the whole ecosystem and platform that develops supports these 3 entities. Agrarian uses container-based technologies and orchestrators in order to achieve the whole integration. Some last-mile accelerators, so emphasizes a lot to the edge computing and to the last-mile connectivity, and also uses hybrid communications, terrestrial and satellite. What Agrarian offers, in the end, Agrarian offers a dynamic programmable distributed ecosystem for hosting all the innovative applications for the end users in the agricultural sector. Offers a decision and support system for the end users, but mainly for the policymakers, and offers efficient resource allocation and seamless connectivity to rural areas, as there we often have these agricultural activities. So all in all, this is a conceptual diagram for Agrarian. The developer enters the platform, develops some applications for the farmers, validate the applications, he makes testings, and the most important is that the developer, of course, in our project we have developers, but with the open calls, we aim to further expand these applications and the technologies for the farmers and the policymakers. So you, as external developers, you will develop your application. You will test it in our platform, in our test beds, and then you will you will put this application to the repository in order to be available for the end user for further testings and evaluations. So as you can see down here, the down layer, the bottom layer, we emphasize, as I said before, much to the seamless connectivity. So we have some hybrid communications, and to the last mile accelerators, mainly to edge computing. So all the applications that you will develop must be implemented in the edge or near the edge of the network, and use hybrid communications, either satellites or terrestrial. We'll further say more about this later on. So what testbeds we have, and you will have to choose one of those testbeds in order to implement there your applications. So far, in this open call, we have a testbed offering satellite communications with edge capabilities using geosynchronous satellite. This is an emulated network, and it is hosted by Democritos. Then we have low Earth orbit satellite communications, again with edge capabilities. This is hosted by DLR. Then, in case you would like to test your application in real hardware that it is used on satellites, then Hubotica has such an emulation testbed with a platform and equipment that is used on real satellites. And then if you would like to experiment and develop application using narrowband IoT technology, then Sateliot is the testbed that you will choose. Of course, except those 4 testbeds, we also offer a dataset for agriculture, and you can use that instead of choosing the previous 4 testbeds. So all in all, you will either use a testbed or the agricultural dataset for your development. Now, what content your application will have? It must address one of the 3 pilots of the agrarian. So the first pilot has to do with livestock monitoring, and specifically in Crete, in Greece. We are coordinating with a livestock owner. He has a herd of sheep and goats. So the first pilot is about that. The second pilot of agrarian is in Romania and has to do with field crops monitoring. And the third pilot is in Portugal and has to do with vineyards management. So the applications that you will develop must be in the context of those 3 pilots. Of course, you don't have to move or to go somewhere, to go to that places, nor to be synchronized with the pilot, the dates with that we will have those pilots. But the content of your applications must be suitable for addressing the challenges of those 3 sectors. So, for you, for the applicants, what to read? You need for sure to read the guidelines for applicants, because in there we describe in detail the whole context of the open call, the timelines, the topics, and we provide further information about your applications. Then the technical annex that we analyze the testbeds and the pilots. And then we have also a lot of questions and answers, all concentrated in a document that we have it available for you. So these three documents are very important before you start writing your proposal. What to attend? We're organizing 2 info days, one today, and the next one is 19th of December. Sophia, it's 19th of December, correct? Because
yes,
I was
yes.
typing and I was just, I didn't see it. Okay,
yes,
thank you.
at 11 CT.
Okay, thank you. We will present different test beds in those 2 days. So today we will present one test bed and one dataset, and the next time we will present the next 3 test beds. I would also recommend to subscribe to our website. Here you can find the QR code. Right now, if you would like, you can scan it and go to the website and subscribe there in order to receive all the information and the emails regarding the open calls. What to choose? As I said before, you need to choose either one and only one test bed, not 2 or 3. So one test bed or the dataset. You cannot choose a combination of those, just one. And then again, just one pilot. Of course, as I said before, no physical presence is needed. We will further discuss about that when we're presenting the test beds. When to apply, the applications the submissions are already open. So from now until the end of January. This is all about me as a fast, quick overview. If you have further questions, you can read the guidelines for applicants, or you can make your questions in the chat. And now we will proceed to the first testbed. Actually, it's the 3rd testbed, but the first for today. So Peter from Ubotica is going to present this one. So I'm giving the floor to Peter. Peter?
Good morning, everyone. Thank you very much. So I'll just share my screen now. Okay, is everyone able to see my screen?
Yes.
Yeah, I think it's up. Okay, thank you. So welcome, everyone. Thank you for joining us this morning. My name is Peter O'Riordan, and I'm an engineer at Ubotica. So Ubotica is an Irish company founded in about 2017, and we specialize in AI-powered Earth observation to provide real-time insights from space. Using AI-powered Earth observation for our achievements include real-time insights, in which our technology enables satellites to process and understand data in real time, providing immediate and actionable information. Cost efficiency by processing data on board at the source. Ubotica reduces the overhead requirements of extensive ground-based infrastructure and data transmission. Satellite autonomy, to understand what it sees and therefore to understand if it has captured useful data or not. So, for instance, if there is cloud coverage in an area, it can choose not to send down data that doesn't cover clearly the landmass. And state of the art. We have been developing our technology specifically to run and deliver fast and accurate insights within the constraints of small CubeSats. So they're very efficient, state-of-the-art architecture. And we will be developing our testbed for last mile edge computing. And the idea being is that on board a satellite, you would capture your imagery and process it there and then right at the edge before sending it back to Earth. So some of the challenges and benefits of onboard data processing. Satellite images can be very large and very difficult to manage. So processing it at the source means that you can, instead of sending the image and processing it on Earth, you can process it on site and choose to send back the useful parts of the image. You can crop out the elements that you don't need, as well as you can just take the pure insights and to say, here is the breakdown of exactly what you would like to have. So there can be a greatly reduced latency and delivering the insights much faster compared to sending large data back to Earth. This also improves cost savings and cost efficiency by reducing the need for extensive ground-based infrastructure and continuous data transmission or long durations of it. Increases efficiency, enabling rapid decision-making and response because you're able to get the insights so promptly. And enhanced accuracy, minimizing the potential data loss, corruption during transmission, and ensuring higher accuracy and reliability within the insights being generated. And the benefits then for agriculture, to gain real-time accurate insights for improved decision-making in such cases as crop monitoring, disease and pest detection, water management, climate impact assessment, precision resource usage. In each of these, in monitoring the crop, you can, in theory, we could monitor the crop status, the growth stages, and optimize the yield capture. Or you might have high area of coverage covering the entire farmland, and therefore you could provide service to very large farms where it takes a lot of manpower to cover certain areas, and to be able to analyze the entire farm and then send specific resources to very precise locations. So it allows very much increased precision resource usage. And this can be used for water management, efficient irrigation to very localized spots, or it could be to fertilizing very specific areas as well. So it enables high precision analysis over an entire farmland. And then essentially we come down into what our emulation or what our testbed is, and that is satellite edge AI compute emulation. And in this emulation testbed, this will be running on a server in Ubotica in Ireland. And essentially this server is online, it's available to use, and it will be incorporating hardware that is used in our flight-ready satellites. So we will not be launching this on board a satellite, but it will be using the same hardware. Our testbed is it's an online platform that connects to a Ubotica server to process the satellite images and generate insights in real time. It's accessible and easy to use, and it will return the insights directly back to your device. And the testbed will enable verification of a model, allowing the development of compatible AI models for Earth observation satellites. And to check, it will also enable verification of the accuracy of the insights, as the models to run on board our CubeSats will need to be ported, and therefore they run at floating point precision, which may be different than what was built in the lab. So it goes through, it will be ported, and it will be compiled to run on our architecture, and just to verify that the results match on other hardware, or from when built from other hardware. The design of it, we'll be using an application that we've developed, and it's very simple to use, and it will be a virtual environment to run, to remotely run inference models on Informatica's space-ready platform. It's codeless, user-friendly, and requires minimal input from users once they are set up and ready to go. How to use Rupia? From Informatica, the user will gain an access token and will also receive the Rupia app. This is a client that will run on your machine, and to use this, it's codeless. There is a small level of adjustment in this JSON file, and that is to indicate where input files are, where the AI model is. This is on the client side. And then when you launch the application, it will send that data seamlessly. It'll handle the send request, and it'll handle the retrieval of the data. So the user just has to point where the input data images and AI model are, and they can choose to fire and forget, or they can choose to wait until the results are back. They can choose to fire and forget if there is a large amount of images, so it'll take some time, and therefore they can move on to other tasks, and they will receive an email as pictured here to indicate when the task. For setup, we'll provide the user an account with the access token. We will assist the users in configuring their JSON file and how to use the application, and then the execution, as I say, is just to run the Rupia application, and it'll handle the rest. So there we have the JSON config in this example. You have a developed and already built AI model, a neural network model, and it will be trained and ready to accept the image samples that will be supplied. And so then the results will be processed on this known architecture and returned to the user. A little bit in a more technical background, this includes that we use an open software, OpenVINO, which is able to port and compile from many different neural network model types, including PyTorch, TensorFlows, ONNX. We were able to optimize these and compile them for our network. And this will be done we will assist in developing some of these models. And where our Rupia application will occur is at this point here, running the inference. Because as I say, the user will not need to have hardware of their own to test this. The Rupia app, again, that's where they send the data off, run the inference, and get their data back. So this is, in this pipeline here, in this development cycle, this is where the Rupia app will lie. And again, a high-level summary of use. Test AI models. This will enable the testing of AI models after they have already been adapted to run at FP16, that's the floating point precision, in a satellite-ready hardware. So the user will provide a pre-trained model, pre-processed satellite test imagery, and reference results. And what we will provide from Informatica, we will provide the Rupia app, the Rupia access token, usage and usage guide. And then we will work together to ensure that the JSON configuration file is set up correctly, and how to compile an AI model for deployment on Rupia. And so in conclusion, Yes, we are running we have the satellites we have the satellite edge AI compute emulation testbed, and this will emulate the capture of data on a satellite, process it, and send the real-time insights back promptly. The use case examples may include water management and crop management and crop monitoring. And then the use case is the Rupia application, user-friendly, codeless platform for easy data handling and insight retrieval. So that's it from Ubotica. Thank you very much.
Thank you, Peter.
And we'll save the questions till the end, isn't that right?
Yes, they
Okay.
can write the questions in the chat, and you
Okay.
can answer in the end. Okay, thank you very much, Peter.
Okay.
Now we continue with the dataset presentation. So, Pius from TeraView, the floor is yours.
Yes, can you confirm that you see the screen?
Yes, you can see it.
Okay, thank you, Michael. Good morning, good afternoon to everyone. This is Piyush Harsh, Managing Director, TeraView GmbH, and I'm going to quickly go over what sort of historical data sets that we will make available to the open call winning proposals. So before going into the details, just quickly about the company TeraView. We are a climate SaaS startup based out of Zurich in Switzerland, where we deliver insights based solely and completely on remote Earth observation data and sensor data from our customers. So we actually naturally have been working with a large amount of historical data sets from Earth observation satellites as well as weather stations, and that is what we are making available as part of the open call. So we will be making available 4 different type of data sets as needed. In terms of the data size, the largest data set will be the LANDSAT Earth observation data, which will contain multispectral as well as the thermal bands for people to work with those. And as well as we have access to the Copernicus global digital elevation maps in different resolutions for Europe as well as globally. We also have Food and Agriculture Organization data set on global soil type, which has been prepared in collaboration with UNESCO. And that offers a resolution of approximately 1 kilometer. So it's 30 arc seconds by 30 arc seconds. And we will also be making available the data from Open Weather Map, which will be going back 40 years in time in granularity of every 15 minutes. All of these data sets we have available with us, and also we have the capability of producing new data sets for regions and agricultural land areas that we have not previously worked upon. So depending on the winning open call proposals, the data sets will be curated and made available for a specific agriculture plots from the participating organizations. I want to quickly present what some of these data sets look like. So here what you see on the screen is a typical data organization for LANDSAT. And essentially these are large tar gzipped files, which upon expansion are arranged nicely by us into logical subfolder structure by year, date, month, and the Landsat WRS coordinate systems. And what you see here are various bands which the constellation captures. Just to give an example here, B1 band is the blue wavelength, B2 is green, B5 is shortwave infrared 16, B10 is long wave infrared, which is actually the thermal infrared if you want to work with the surface temperature in your calculations. The post-processed pixel resolution that we will provide will be of 30-meter radius. And here we will also do pre-filtering by quality bands. So for instance, on days when there are significant cloud cover and that data is with a reasonable probability not useful for model computations, then we have the capability of filtering it out and only making available the usable data sets to the winning participants. Let's take a look at the harmonized soil data set that we can make available. That will have a 1 kilometer resolution. So as I said before, 30 arc seconds by 30 arc seconds granularity. And the metrics normally available from this data sets are including organic carbon content in the soil, pH values, water storage capacity, soil depth, cation exchange capacity of the soil, etc. So that will be made available most likely as a CSV file. And from open weather data, what we will provide is we'll provide historical weather information to the participants going back 40 years in time and with a 15 minutes granularity. And here is an example of the metrics which are available in this data sets. This is just a subset. There are 100 more fields. So you can imagine also wind velocity, wind direction, humidity, precipitation, sunlight duration, etc. All of those are available in this data set, which we will make available. That is all I want to tell you about the data sets, and I'll hand it over to Michael.
Thank you, Pius. If anyone has any questions, again, he can write in the text. And then now we're going to present you the platform that you're going to use for your submissions. So Costa, the floor is yours.
Thank you, Michael. Let me share my screen. Can you confirm is my screen shared?
Yes.
Okay, thank you. Hello, everyone. The purpose of my presentation is to show you how an applicant can register in our application and submit a proposal for the agrarian call. Okay, let's get started. We have to visit agrarian.appliobox.gr. We can see the login page. And to register our application, we have to click the link register here. And we fill our input to the registration form. And we click register. Verification email is sent to our email account. This is the email that you will receive. We press verify our email, and then we are redirected to agrarian.appliobox.gr again, and our account is verified. Now with the email and the password that we have set, we can log into the AppleBox. And when we are successfully logged in, we can see in the first page, we can see the calls that are published from the agrarian call, and the phase that the call is at the moment. As you can see at this moment, it's for submission phase. It's in submission phase. We click more info, and here we can see the dates that the submission phase, that the call is open for submission. We can see some overview, small description about the call. Down here, as Michael mentioned before, we can download all the documents related to the call, applicant guidelines that will help us to fill the inputs that will be required for the proposal, the technical annex, and you can download the FAQs. Now, if we press apply, the inputs for the proposal is loaded. Here we have the basic info section that we put all required data. We choose the testbed that we want to apply for, and the pilot section. If we go further down, there's the technological maturity and self-assessment inputs. And more down, in this section, we have to download the templates from this button here, download the templates. It's a zip file that will include 2 documents, the proposal form and the SME declaration. The proposal form template we have to be filled and uploaded as a PDF. And also, if SME declaration document needed, will be uploaded as a PDF too. In the section, there's a eligibility self-declaration. There are some questions that you have to answer before submitting the proposal to be valid. And when we confirm on this checkbox and we press the save draft, and your proposal is saved as draft. To finalize our proposal, and this is something that I want you to notice, is that we have to click the submit button. The submit button will finalize your proposal inputs and then the upload documents that you have. We'll click submit. There's a flash message that your proposal was submitted successfully, and the date. You can see the date of your submission. This procedure can be done. You can modify if you want, and you can modify your inputs or your documents if you want, and resubmit your proposal as many times you want until the due date of the submission phase. This is the email that you will receive after your submission that you will confirm that you have submitted successfully your proposal. In this section, in my proposals, you can see, as I told you, your proposal and resume your proposal or make any modifications if you want. And in the FAQs, we have the most frequently asked questions that you can see and will be updated. Finally, we have a reset password functionality in our platform. If an applicant forgets his password, in the login page, there is a forget password link that you can press it and put your email in the input. And a reset password email will send to your email account. You press reset password, and here you can put your email and the new passwords that you want to set. That's all for me. Thank you very much.
Thank you, Costa. So as I can see from the chat, we don't have any questions. So I guess we present everything very nicely and you understood everything. Once again, I would like to say that although your applications need to address one of the pilots, You don't a physical presence is not needed, so you don't have to go to the actual pilot sites. I don't know if anybody has any questions. Otherwise, if none of the presenters also want to add something, we can finish here. Okay, so this meeting will be available on our YouTube channel, the recording. And if you need anything, we will have, of course, the second info day. Otherwise, you can send what you need, any questions or whatever. You can send in the email, in the dedicated email about the support of the open call. You can find everything on our website. So if we don't have anything else, we can finish here. Okay, we don't have anything. So thank you very much for your participation. And we will meet again on 19th of December.